Hello everyone. As you know, we were dealing with the chemical properties of phenol, and the chemical properties of phenol were divided into three categories. This is the chemical formula of phenol. Benzene ring was connected with OH group. The first chemical reactions were those in which oxygen-hydrogen bond was breaking and there was a release of H positive ion. Means those chemical reactions in which phenol was working as an acid. Second chemical properties were those in which oxygen-carbon bond was breaking. Now the third chemical reactions are those in which benzene ring is involved, which are known as electrophilic substitution reaction. The topic is involved in 12th, JEE, NEET and BSc. Let's start. Electrophilic substitution reactions already we have done for halorine also. What are electrophilic substitution reactions? Those reactions in which strong electrophile will replace or substitute weak electrophile. Such reactions are known as electrophilic substitution reaction. And what are electrophiles? The species which attack on electron, and they have a shortage of electron, that's why they used to attack on electron, like NO2 plus 1. Here nitronium ion, nitrogen have a shortage of electron, that's why it is carrying a plus 1 charge over here. So this nitrogen will attack on electrons. So this whole molecule will work as a electrophile. H positive, hydrogen have a shortage of electron, that's why it is carrying a positive charge, and if you will place electron in front of it, obviously it will attack on it. So such particles are known as electrophile. In 11th class they were present. Please check. Two type of they are positive electrophiles and also neutral electrophiles like AlCl3. In neutral electrophiles, the central atom, here central atom is aluminium, will have vacant orbital. Electrons are not available in the orbital, so this atom have a tendency to gain electrons. So this whole molecule is working as a electrophile. And what kind of electrophile? Neutral electrophile. So in these reactions, electrophilic substitution reaction, strong electrophile will replace weak electrophile. Now the reactions we are talking about phenol, let's first understand in phenol which electrophile is available. First, this hydrogen. This hydrogen is connected with oxygen, and oxygen is more electronegative than hydrogen. So these electrons are more toward oxygen side. Now hydrogen is losing its electron, so partial positive charge is there. Positive charge means this hydrogen have a shortage of electron, means it can work as an electrophile. Whereas oxygen is getting extra electron of hydrogen, so partial negative charge will come on it. Similarly, this hydrogen is connected with carbon, and carbon is more electronegative than hydrogen, so obviously electrons are shifted toward carbon side. Again, this hydrogen is losing control on its electrons, so positive charge will develop on it. So means this hydrogen also have a shortage of electron, that's why it is working as an electrophile there. Same rest hydrogens. Rest all hydrogens will have a same problem. Their electrons are going toward carbons due to higher electronegativity of carbon, that's why they are carrying a positive charge. Means total 6 hydrogens are there which can work as an electrophile there. They all are working as electrophile, you can check, they have a shortage of electron. Now in electrophilic substitution reaction, obviously these hydrogens will be replaced by another electrophile. Let's assume another electrophile is E, which is also carrying a positive charge. So this electrophile needs electron. Now which atom can provide electrons to it? Because it is looking for electron. Which atom can provide electrons to it? Let's check. Oxygen is available because oxygen have a lone pair, as well as these electrons are shifted toward oxygen. So electrophile can attack on oxygen and can replace this hydrogen. Okay. Second option, this electrophile can attack on carbons. This is carbon over here. For electron, this electrophile can attack this carbon and can replace this hydrogen. Okay. This electrophile can attack on this carbon and can replace hydrogen and get electrons. Similarly, it can attack on this carbon and can gain electrons from the carbon and can replace this hydrogen. Similarly, this attack means this new electrophile, which is stronger than hydrogen, have these possibilities. It can attack on oxygen and it can attack these 5 carbons for electron. But all these attacks are possible? The answer is no. Look, let's check this attack. Can it attack on oxygen? Okay, oxygen is a high source of electron, but oxygen is very, very high electronegative atom. Its electronegativity is 3.5. So definitely, due to very high electronegativity, it is not going to give electron to electrophile easily. What electrophile wants? Electron. What it wants? Electron. Will oxygen give it electron easily? The answer is no, because oxygen is highly electronegative. It will hold its electron strongly, so it is not going to deliver its electron easy to electrophile. Means if electrophile is attacking on oxygen, it is not going to get electrons. That's why this attack will be hindered by electrophile. Electrophile will not go for oxygen for the electrons. Okay. Carbons. Carbons have less electronegativity, only 2.5 electronegativity they have. So these carbons can easily provide electrons to electrophile. But can all carbons? Look, this is OH group, functional group. Next carbon to functional groups are known as ortho. Next to ortho, meta. And next to meta, para. Now, note down, electrophile will attack on ortho and para carbon for electrons, not on meta carbon. Only ortho and para. Carbon will be attacked by incoming electrophile, this new electrophile. And obviously, if it will attack on ortho and para position, these ortho and para hydrogens will get substituted, not on meta. Not on meta. Means if I am going to perform this reaction, so product will be this. This new electrophile is going to make bond with either carbon of ortho position and hydrogen will be replaced. Look, when this hydrogen will break bond from carbons, obviously electrons will be shifted toward carbon because this hydrogen is less electronegative as compared to carbon. So it will release out as H positive. So let's remove it as H positive. Second option, this is ortho attack. This E can attack on a para position here also, and same will happen. This hydrogen will be replaced by E, means incoming electrophile, and H positive will be released out. This product will be known as ortho substituted product, and this product will be known as para substituted product. For example, Like I am going to react phenol with concentrated H2SO4 and heat. In this condition, let me tell you, this reagent will provide you which electrophile? Sulfur trioxide gas, SO3. We will discuss all these reactions separately, but as an example here I am telling you. Now, sulfur trioxide is a neutral electrophile. Sulfur have a shortage of electron. With its shortage orbital, it will attack on benzene ring for electrons. Which position? Ortho and para. So on ortho and para, hydrogens are available. So first product, ortho product, SO3, and the replaced hydrogen will be joined with it. H. Mechanism we will discuss later. Ortho substituted group product we got. Similarly, one more product you will make. This one. At para position it will attack and we will get a para substituted product. Similarly, if the reagent is changed, suppose I have a reagent concentrated H2SO4. These all reagents I have discussed with you when I was doing electrophilic substitution reactions of halorine, and mechanisms I have told there. So this reagent will make which electrophile? Nitronium ion, positive electrophile. So nitronium ion is an electrophile. What it wants? Electron. Electron will be provided on what positions? Ortho and para position of a benzene ring. So two products will be generated here. NO2 will join here and it will replace H positive. This hydrogen will be replaced by NO2. You can check. This is electrophile and it has substituted another electrophile. So that's why we are calling it electrophilic substitution reaction. This is ortho substituted product. Second option where it can attack para position. Here we have para position. This is para position. H positive will be eliminated out like this. So two products are possible here, ortho and para substituted products, not on meta. Now for this video, what is the conclusion? The conclusion is these electrophiles will never attack on oxygen for the electron, will never attack on a meta position of the carbon. Only they will get electrons from ortho and para position. That's why they will substitute hydrogens which are present on ortho and para position. On the basis of that, you have to make these products, ortho substituted product and para substituted product. Now, which electrophile is going to attack? It depends on reagent. I will tell you all the reagents. Already I have told to you in halorine substitution reactions. You can check that video also. Same reagents here we have for phenol. Now, the last point in this video, between ortho and para, para will be major product. And ortho will be minor product. Reason is because in ortho case you can check the groups are very close to each other, due to which these groups will feel repulsion, which we call steric hindrance. Due to steric hindrance, the molecule will become unstable. But here the two groups are far away from each other. Repulsion problem means steric hindrance problem will not be there. That's why this product will be in higher amount as compared to this product. Out of 100%, 1 or 2% products are ortho major products. Mostly para products are major. 1 or 2% ortho products are major product. They are exceptional case. They have some different reason for that. Like in this case, ortho will be major product. I will tell you why when I will discuss it separately, like nitration, sulfonation. There I will tell you the exact reason for that. But mostly para will be the major and ortho will be the minor product. Reason, in ortho the atoms or groups of atoms are very close. They are feeling repulsion, which we call steric hindrance, which will create instability in the molecule. So unstable molecules will not be preferred by the reaction. So very less amount of ortho products will generate. And para, because the groups are far away from each other, you can check they are exactly in opposite direction. So no such steric hindrance problem is there. So most of the molecules will be para substituted product. Now the question arises, why only ortho and para, not meta position? Why oxygen is not attacked by electrophile? I have given the answer. Because oxygen will not give electrons easily to the electrophile, because oxygen is highly electronegative atom. But why not metacarbon? Only ortho and para carbons are attacked by electrophile. Check in next video. Thank you very much.